Picture this. You're descending through the inky blackness of the Pacific Ocean, miles beneath the surface where sunlight has never touched. The crushing pressure would instantly kill any human, yet something impossible is happening down there. Oxygen is being created in complete darkness, not by plants, not by algae, but by rocks sitting on the ocean floor. This discovery has scientists questioning everything they thought they knew about life itself. What I'm about to reveal challenges our most fundamental assumptions about how oxygen forms on our planet. For billions of years, we believed photosynthesis was the only way to produce the oxygen we breathe. Plants and marine organisms convert sunlight into energy, releasing oxygen as a byproduct. This process built up the atmosphere that allows complex life to exist on Earth. But deep beneath the waves, something entirely different is occurring that could rewrite the story of life itself. The discovery happened by accident in one of the most remote places on Earth. Scientists weren't looking for revolutionary breakthroughs about oxygen production. They were studying the Clarion-Clipperton Zone, a massive underwater region in the Pacific that spans an area larger than Mexico. This zone has become incredibly valuable because of what lies scattered across its seafloor. Billions of strange potato-shaped rocks called polymetallic nodules contain precious metals essential for our modern technology. These nodules don't look like much. They're dark, lumpy formations that have been growing on the ocean floor for millions of years. Metals dissolved in seawater slowly accumulate around tiny pieces of shell or debris, creating these unusual structures. Inside each nodule, you'll find manganese, nickel, copper, and cobalt. These elements are absolutely critical for manufacturing the batteries that power everything from smartphones to electric vehicles. As our world becomes increasingly dependent on clean energy technologies, these deep-sea treasure chests have attracted the attention of mining companies worldwide. 16 different contractors now have permission to explore vast sections of the Clarion-Clipperton Zone's seafloor. They're using sophisticated equipment to map the area and assess how much valuable metal lies waiting in the depths. This industrial interest sparked scientific curiosity about what else might be happening in these unexplored regions. Researchers began collecting sediment samples from the seabed using advanced robotic systems, and that's when everything changed. The instruments started detecting something that shouldn't exist. Massive amounts of oxygen were being produced on the seafloor in total darkness. The readings were so unexpected that scientists initially assumed their equipment was malfunctioning. Every previous study of deep-sea environments had shown oxygen being consumed, not created. The deeper you travel into the ocean, the less oxygen you find in the water. By the time you reach depths of just 3,000 feet, oxygen levels become extremely low. This oxygen depletion happens for logical reasons. The water is too far from the surface for any exchange with the atmosphere above. Meanwhile, deep-sea organisms and bacteria are constantly using up whatever oxygen remains as they break down organic matter that drifts down from higher levels. Oxygen production at these depths seemed scientifically impossible, but the mysterious readings persisted for an entire decade. Different research teams using different equipment kept detecting the same phenomenon. Finally, scientists realized they weren't dealing with faulty instruments. Something was actually creating oxygen in the pitch-black depths of the ocean. The source turned out to be those unremarkable metal nodules scattered across the seafloor. These rocks were functioning like natural batteries. When you place a battery in seawater, it creates bubbles through a process called electrolysis. The electric current splits water molecules into hydrogen and oxygen. The nodules were doing exactly the same thing, but in their natural state on the ocean floor. Each individual nodule carries an electrical charge of about 9/10 of a volt. That's not quite enough power to split seawater molecules, which requires approximately 1.5 volts. However, when these nodules cluster together in groups, their combined electrical output becomes much more powerful. The clustered formations can generate enough voltage to trigger the electrolysis reaction that splits seawater and produces oxygen. Essentially, the seafloor was operating like a massive natural battery farm, generating electric current strong enough to create oxygen without any sunlight whatsoever. This phenomenon has earned the name dark oxygen, and its implications extend far beyond marine chemistry. The discovery of dark oxygen forces us to completely reconsider how life began on our planet. For over 3 billion years, we've operated under the assumption that photosynthesis came first, creating the oxygen that allowed complex organisms to evolve. But this creates a fascinating paradox. Plants need oxygen to survive, yet they're supposedly the original source of oxygen. It's the ultimate chicken and egg dilemma that has puzzled scientists for generations. Dark oxygen production offers a potential solution to this ancient mystery. If metal nodules and similar geological formations were generating oxygen long before the first plants evolved, then early life forms could have accessed this vital element without waiting for photosynthesis to develop. The ocean floors of primordial Earth might have been humming with electrical activity, splitting water molecules and creating oxygen-rich pockets where the earliest organisms could thrive. This revelation doesn't just change our understanding of Earth's past. It opens up entirely new possibilities for finding life beyond our world. Consider the frozen moons orbiting the gas giants in our solar system. Europa, circling Jupiter, and Enceladus, orbiting Saturn, both harbor vast liquid oceans beneath their icy surfaces. These alien seas contain dissolved salts and minerals that could form structures similar to our ocean's metal nodules. If dark oxygen production is occurring in these distant underwater worlds, they might harbor oxygen-breathing life forms in environments we never thought could support them. We wouldn't need to find planets with perfect atmospheres and abundant sunlight. Instead, we could discover thriving ecosystems in the perpetual darkness of alien oceans, powered entirely by natural electrical processes. The implications stretch even further when we consider exoplanets orbiting distant stars. Our search for habitable worlds has focused heavily on finding planets in the Goldilocks zone where liquid water can exist on the surface. But dark oxygen production suggests we should expand our definition of potentially habitable environments. Rocky planets with subsurface oceans and the right mineral compositions could support life even if they receive no sunlight whatsoever. However, this groundbreaking discovery comes with significant complications. The same metal nodules producing dark oxygen are exactly what deep-sea mining companies want to harvest. The irony is striking. These formations took millions of years to develop, slowly accumulating the precise mineral combinations that allow them to generate electricity and split water molecules. Mining operations could destroy these natural oxygen factories in a matter of hours. The mining process involves sending massive underwater vehicles to crawl across the seafloor, collecting nodules and disturbing sediment layers that have remained undisturbed for millennia. The environmental impact extends far beyond simply removing rocks from the ocean floor. These nodules appear to play crucial roles in supporting deep-sea ecosystems that we barely understand. The Clarion-Clipperton Zone hosts an incredible diversity of mysterious creatures adapted to life in complete darkness. Scientists estimate that 90% of the species living in these depths remain unknown to science. We're talking about ghostly sea anemones, bizarre deep-sea cucumbers, and countless other organisms that have evolved in this unique environment over millions of years. These creatures might depend on dark oxygen production in ways we haven't yet discovered. Removing the nodules could collapse entire food webs and eliminate species before we even know they exist. The mining operations might inadvertently destroy the very processes that have sustained life in these remote ocean depths for geological ages. The timing of this discovery creates an urgent dilemma. Global demand for the metals contained in these nodules is exploding as we transition to renewable energy technologies. Electric vehicle batteries, solar panels, and wind turbines all require the exact materials found in these deep-sea formations. Some projections suggest demand could increase by 600% in the coming decades. We're faced with a profound choice. We can harvest these materials to build the clean energy infrastructure needed to combat climate change on the surface. Or we can preserve these underwater ecosystems and their remarkable oxygen-producing capabilities that might represent entirely new forms of life support systems. The answer isn't simple, and it requires far more research than we currently possess. We need to understand exactly how dark oxygen production works, what role it plays in supporting deep-sea life, and whether mining operations would permanently disrupt these processes. We're making decisions about environments we've barely begun to explore, potentially affecting life forms we haven't even discovered yet. Dark oxygen represents one of the most significant scientific revelations of our time. It challenges fundamental assumptions about how life develops and where we might find it throughout the universe. But it also reminds us how much we still don't know about our own planet. In our rush to exploit Earth's resources, we might be destroying processes that have operated successfully for millions of years. The deep ocean continues to hold secrets that could revolutionize our understanding of life itself. Dark oxygen is just the beginning. Who knows what other impossible processes are occurring in the crushing depths, waiting for us to develop the technology and wisdom to discover them responsibly.